March 7th, 1945. Remagen Bridge, Rhine River. Hauptmann Ernst Schneider crouched in the rubble of what had been a German command post, examining the radio equipment his reconnaissance team had just captured from an abandoned American armored column. The SCR-508 set sat intact, its dials still warm, frequencies marked in careful American handwriting on a card taped to the casing. His signals officer, Lieutenant Karl Becker, was already connecting a field battery to the American radio. Static hissed through the speaker. Then voices, calm, methodical, speaking in English with the distinctive flatness of the American Midwest. Baker 2-1, this is Baker 6. Continue advance to phase line blue. Charlie Company will cover your right flank. Over. Schneider understood English well enough. He'd studied engineering at Technical University before the war, but it wasn't the language that made his hands go cold. It was what he was hearing, real-time coordination, multiple tank companies, speaking to each other as if they were standing in the same room, but they weren't in the same room. According to the map coordinates being transmitted, these American units were spread across 15 kilometers of front. How many frequencies are active? Schneider asked. Becker adjusted dials, his face growing pale. Herr Hauptmann, I'm counting at least 27 separate American radio nets within range. Battalion level, company level, even individual tank commanders talking directly to each other. They're coordinating armor movements across the entire sector simultaneously. Schneider had commanded a Panzer company in France in 1940. He'd fought in Russia in 41 and 42. He understood armored warfare. He understood what coordination meant in tank combat. What he was listening to shouldn't have been possible. The Americans were operating 500 tanks as if they were a single organism, each unit aware of every other unit's position, each commander able to request support or redirect forces in seconds, not hours. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. German Panzer doctrine had been built on radio silence. Commanders communicated through motorcycle couriers, through pre-arranged signals, through careful pre-battle planning. Radios were used sparingly, mainly for receiving orders from higher command, never for constant chatter between units. The reasoning was sound. Radio transmissions could be intercepted. Direction-finding equipment could locate transmitters. Every radio broadcast was a potential death sentence. But the Americans didn't care. They broadcast constantly. They coordinated in real time. And somehow, impossibly, they were winning because of it. Schneider looked at the American radio again. It was compact, ruggedized, clearly designed for mass production. He estimated weight at perhaps 35 kilograms. His own company's radios, the Feld Fu Punkt B sets, weighed nearly twice that, required careful maintenance, failed constantly in cold weather or rough handling. This American equipment looked like it had been dropped from a moving vehicle, dragged through mud, and it still worked perfectly. The implications began crystallizing in his mind. If every American tank had reliable radio equipment, if every tank commander could communicate instantly with every other commander, then American armored formations could adapt in real time to battlefield conditions. They could concentrate forces at weak points instantly. They could call for air support within minutes. They could coordinate with artillery, with infantry, with logistics units, all simultaneously. German forces still relied on 1930s technology and doctrine, rigid pre-battle plans, motorcycle couriers racing between units, company commanders making decisions based on information that was minutes or hours old. Against an enemy using modern communications, it was like fighting blind against an opponent who could see everything. To understand what Schneider had discovered, you must first understand what Germany had built. September 1st, 1939, Poland. German panzer divisions demonstrated blitzkrieg for the first time. The doctrine was revolutionary. Fast-moving armoured columns concentrated at weak points, breaking through enemy lines, exploiting deep into rear areas. France fell in 6 weeks in 1940. The Soviet Union was invaded in 1941 with initial devastating success, but German armoured doctrine had a fundamental assumption that commanders would lead from the front, that they would make decisions based on direct observation, that careful pre-battle planning would eliminate the need for constant communication adjustments. Radio communication was viewed with suspicion. It violated operational security. It created electromagnetic signatures that enemy intelligence could exploit. It encouraged junior officers to question orders or request clarification. The German Army of 1945 still operated under these assumptions. Company commanders received orders from battalion. They planned their attacks carefully. They briefed their subordinates. Then they executed, maintaining radio silence except for critical emergency transmissions. If situations changed, if unexpected resistance appeared, if opportunities emerged, response time was measured in tens of minutes or hours. Motorcycle couriers had to physically travel between units. Company commanders had to make decisions with incomplete information about what other friendly units were doing. Ernst Schneider had experienced this limitation personally. June 19, 1944. Normandy, near Villers-Bocage. His Panzer company, 12 Panther tanks, had been ordered to counterattack American forces that had broken through German defensive lines. The attack was planned at 0400 hours. By 0600, when the attack jumped off, the tactical situation had completely changed. American forces had advanced 3 kilometers beyond where German intelligence placed them. Schneider's company advanced into an ambush. American tanks, dug into hedgerow positions, opened fire at close range. Within 10 minutes, 5 of Schneider's Panthers were destroyed or disabled. He tried to radio for support from the neighbouring company. Radio silence protocols meant the other company couldn't respond. They didn't know Schneider's unit was being destroyed. By the time a motorcycle courier reached them, 40 minutes later, Schneider had lost 8 tanks and was retreating with the 4 survivors. If he'd been able to communicate instantly with neighbouring units, coordinate a flanking movement, call for artillery support in real time, the outcome would have been different. But German doctrine didn't allow for that kind of flexibility. And German radio equipment, even when used, was unreliable. The Feldfou sets issued to German armoured units were complex pieces of equipment. They required skilled operators. They needed careful tuning. They were sensitive to vibration and moisture. Schneider remembered the constant frustration. Radios that worked perfectly in garrison would fail within days in field conditions. Vacuum tubes would break. Connections would corrode. Operators needed specialized training that took months. By contrast, the American SCR-508 sitting in front of him looked like it had been designed by someone who understood that soldiers would break things. Solid construction, simple controls, waterproof housing. Everything about it screamed mass production and reliability. Becker was still listening to American radio traffic, taking notes. Herr Hauptmann, they're coordinating an entire armoured division's movement. I'm hearing battalion commanders talking directly to regimental headquarters. Company, commanders requesting artillery support and getting responses within seconds. Tank commanders reporting enemy positions and having that information immediately broadcast to all units in the sector. Schneider moved closer to listen. The American voices continued their calm, methodical coordination. All Baker elements. This is Baker 6. Reconnaissance reports enemy armour concentration grid 573218. Charlie Company will fix with frontal pressure. Baker Company will execute flanking movement from north. Artillery fire mission being coordinated now. All units acknowledge. A chorus of acknowledgements came back. Baker 2-1, Wilco. Baker 2-3, Roger. Baker 3-1, acknowledged. The entire manoeuvre, involving potentially 100 tanks, was being coordinated in real time over the radio. Information flowed instantly. Commanders could adjust tactics based on immediate battlefield reports. Artillery support was integrated seamlessly. Schneider had seen German attempts at similar coordination. It required hours of planning, staff officers drawing maps, couriers distributing written orders, telephone lines being laid by signals companies. And all of that careful planning became useless the moment first contact with the enemy changed the tactical situation. The Americans had solved this problem with technology and doctrine. Give every tank reliable radio equipment. Train every commander to communicate constantly. Accept the security risk in exchange for overwhelming coordination advantage. The security risk was real. German signals intelligence units regularly intercepted American radio traffic. Direction-finding equipment located American transmitters. But it didn't matter. The Americans broadcast so much, on so many frequencies, with so many units transmitting simultaneously, that German intelligence was overwhelmed. Finding one American radio net among dozens was pointless, when by the time you located it, the unit had already moved, and accomplished its mission. More importantly, the Americans had something Germany lacked. They could replace losses faster than Germany could inflict them. If a tank with a radio was destroyed, another tank with an identical radio took its place. If a radio operator was killed, another trained operator replaced him within days. American logistics supported this communication infrastructure with spare parts, replacement equipment, trained personnel flowing forward constantly. German armoured units by March 1945 were operating with equipment dating back to 1941 or earlier. Replacement parts were scarce. Trained signals personnel were critically short. Radio sets that failed couldn't be repaired because vacuum tubes and specialized components were unavailable. Many German tank companies were operating with only one or two working radios, and those were used only for receiving orders from higher command, never for coordination between units. Becker handed Schneider a list he'd compiled. In the last hour, I've identified these American units on the radio: 3rd Armored Division, 7th Armored Division, 9th Armored Division, all operating in this sector, all coordinating with each other. They're even communicating with tactical air support. I heard a tank commander request airstrike on a German position, and less than 10 minutes later, American fighter bombers appeared. 10 minutes from request to airstrike. Schneider knew German requests for Luftwaffe support in March 1945 went unanswered. The Luftwaffe barely existed anymore. But even when it had existed, coordination between ground forces and air support took hours or days. Elaborate procedures. Written requests sent up chain of command. Mission planning. Briefings. By the time German aircraft arrived over the battlefield, the tactical situation had changed completely. The Americans did it in 10 minutes. Because tank commanders could talk directly to forward air controllers. Because forward air controllers could talk directly to pilots. Because everyone in the American military seemed to have a radio and permission to use it. The technological gap was stunning. But what disturbed Schneider more was the doctrinal gap. Germany had built an army around the concept of Auftragstaktik, mission-type orders. Give subordinate commanders an objective, trust them to accomplish it using their own initiative and methods. In theory, this should have created flexibility and adaptation. But in practice, without reliable communications, Auftragstaktik meant subordinate commanders operated blind. They couldn't coordinate with neighboring units. They couldn't request support when situations changed. They couldn't adapt their methods because they didn't know what was happening beyond their immediate observation. The Americans had taken the opposite approach. Give everyone radios, let everyone communicate, create a system where information flowed freely in, all directions. Junior officers could talk to senior officers. Neighboring units could coordinate directly. Support elements could respond immediately to frontline requests. It looked chaotic on the surface. All that radio chatter, all those voices talking over each other. But it created something Germany couldn't match. A responsive, adaptive military organization that could react to changing battlefield conditions in minutes instead of hours. Schneider thought back to his experience in France in 1940. Back then, German communication superiority had been decisive. German tanks had radios when French tanks didn't. German commanders could coordinate while French commanders sent runners or used flag signals. The advantage had been overwhelming. French armoured forces, often superior in numbers and tank quality, were defeated because they couldn't coordinate effectively. German Panzer divisions operated as unified formations, while French tanks fought as individual vehicles or small groups. Now, in 1945, the situation had reversed. The Americans had communication superiority, and Germany was experiencing what France had experienced in 1940. Technological inferiority, creating tactical paralysis. Becker interrupted his thoughts. Herr Hauptmann, American units are reporting they've secured the Remagen Bridge. They're coordinating movement of multiple divisions across the Rhine. I'm hearing traffic about engineers checking bridge structural integrity, about anti-aircraft units being positioned, about follow-on forces being directed to crossing points. They've captured a bridge over the Rhine, and within hours they're moving entire divisions across because every unit knows exactly what every other unit is doing. The Remagen Bridge. Schneider knew what that meant. The Rhine was supposed to be the final defensive barrier. Every bridge was supposed to be destroyed before American forces could capture it. But somehow the Americans had seized this bridge intact. And now, using their superior communications, they were exploiting the breakthrough with a speed Germany couldn't counter. If this had happened to a German army, if German forces had captured a critical bridge, the exploitation would take days. Higher command would need to be informed. New orders would need to be drafted. Units would need to be redirected through normal chain of command. Logistics would need to be reorganized. The entire process would be methodical, careful, slow. The Americans did it in hours. Because tank commanders were already talking to higher headquarters. Because division commanders could instantly redirect battalions. Because logistics officers were listening to the same radio nets and could adapt supply routes without waiting for formal orders. Schneider examined the American radio more carefully. He noticed details. The frequency dial had clear markings. The power switch was simple, robust. The antenna connection was standardized. Everything about the design suggested it had been engineered for soldiers who weren't radio specialists, for tank commanders who needed to focus on fighting, not on troubleshooting complex electronics. German radio sets, by contrast, required specialist knowledge. Tuning procedures were complex. Maintenance was technical. Operating a German field radio was a job for trained signals personnel, not something every tank commander did routinely. This fundamental design philosophy difference reflected deeper cultural differences. American industry designed equipment for conscripts, for citizen soldiers with minimal technical training. German industry designed equipment for professionals, for career soldiers with specialized education. The consequence was predictable. America could train thousands of radio operators in weeks. Germany needed months to train each specialist. America could replace lost equipment from vast production lines. Germany struggled to maintain existing equipment with scarce replacement parts. America built systems that worked despite minimal maintenance. Germany built systems that required constant expert attention. Schneider had the American technical manual for the SCR 508 in his hands now. His signals officer had found it in the captured American vehicle. The manual was printed on waterproof paper. Illustrations were clear, simple. Operating procedures were written in plain language. Troubleshooting guides were designed for users with no technical background. Even the title page reflected American mass production philosophy. Radio Set SCR 508. Manufactured by Galvin Manufacturing Corporation, Chicago, Illinois. Galvin Manufacturing, Schneider knew that name. Before the war, they'd made consumer radios under the brand name Motorola. Now they were making military equipment. The same company that built radios for American living rooms was building radios for tanks. This wasn't Telefunken or Siemens, producing specialized military hardware. This was a consumer electronics company, applying mass production techniques to military requirements. The implications were staggering. If American consumer electronics companies could produce military radios, then American production capacity for communications equipment was essentially unlimited. Every radio factory in the United States, every electronics manufacturer, could be converted to military production. Germany's specialized military electronics firms already struggling with bombing damage and material shortages, couldn't possibly compete. Becker was documenting the American radio nets, creating a diagram of the communications architecture. Herr Hauptmann, I think I understand their system now. Each tank has a radio. Company commanders have radios that can reach battalion headquarters. Battalion commanders have radios that reach regimental headquarters. But here's what's different from our system. The radios aren't just for vertical communication up and down the chain of command. They're configured for horizontal communication between units at the same level. Schneider studied the diagram. In German doctrine, communication flowed vertically. Company commander reported to battalion, battalion reported to regiment. Orders came down the same chain. A company commander couldn't communicate directly with another company commander in a different battalion. That would violate chain of command protocols. But the Americans had designed their system differently. Tank commanders could talk to other tank commanders. Company commanders could coordinate directly with neighboring companies. The entire organization was networked, not hierarchical. They call it a radio net, Becker continued. Multiple radios tuned to the same frequency, all able to transmit and receive. Everyone on the net hears everything. If a tank commander spots enemy positions, every other tank commander on that net knows immediately. If a company needs support, every company on the battalion net hears the request and can respond. This violated everything Schneider had learned about military communications security. Broadcasting tactical information on open frequencies where anyone could listen seemed insane. But the Americans had calculated differently. The advantage of instant coordination outweighed the security risk, especially when you had such overwhelming material superiority that even if the enemy knew your plans, they couldn't stop you. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. March 8, 1945. 24 hours after capturing the American radio equipment, Schneider received orders to counterattack American forces, expanding the Remagen bridgehead. His Kampfgruppe, battle group, consisted of 16 Panther tanks, 2 companies of Panzer grenadiers, and a battery of 88mm anti-tank guns. On paper, a formidable force. In reality, a collection of understrength units scraped together from shattered divisions. The attack plan was developed at division headquarters, transmitted to Schneider via courier at 0300 hours. Written orders on paper. Attack at 0600. Advance along designated route. Objective was to reach the Rhine and cut off American forces that had crossed. Coordination with neighboring battle groups would occur through division headquarters. If Schneider encountered problems, he was to send situation reports via courier or radio to division, and division would coordinate response. Standard German procedure. Rigid, hierarchical, dependent on communication links that would inevitably fail under combat conditions. Schneider briefed his company commanders at 0430. By the time the briefing finished and commanders returned to their units, it was 0515, 45 minutes before the attack. No time for subordinates to reconnoiter. No flexibility to adapt if intelligence was wrong. Just execute the plan as written. The attack jumped off on schedule. Within 20 minutes, everything went wrong. American forces were not where German headquarters believed them to be. Instead of encountering isolated American units, Schneider's battle group ran into the 3rd Armored Division, a full American armored division with over 200 tanks, all coordinated by radio, all aware of each other's positions. The first indication was when his led Panther Company reported contact with American armor, not a few tanks, dozens of tanks, coming from multiple directions simultaneously. Schneider tried to radio division headquarters for updated intelligence. No response. Either the radio wasn't working properly, or division was overwhelmed with reports from other units, or the signals officer at division hadn't received his transmission. He sent a motorcycle courier. That would take 30 minutes, minimum for the courier to reach division, deliver the message, and return with new orders. In 30 minutes, the tactical situation would change completely. Schneider made the decision every German commander had to make in combat: act on his own initiative or wait for orders from higher headquarters. He chose to act. He ordered his Panther companies to execute a fighting withdrawal to more defensible positions. But his company commanders couldn't coordinate the withdrawal effectively because they couldn't communicate with each other in real time. One company pulled back too quickly, exposing the flank of the neighboring company. That company took casualties from American tanks that exploited the gap. The anti-tank gun battery was supposed to provide covering fire, but they didn't know the Panzers were withdrawing because the courier Schneider sent to them was killed by artillery fire. By 07:30, 90 minutes into the attack, Schneider had lost 6 Panthers, 3 anti-tank guns, and dozens of Panzer grenadiers. The attack had failed completely, and he still hadn't received any communication from division headquarters. The courier he'd sent earlier finally returned at 0800. Division's response was predictable: continue the attack as planned. Division was not aware that the tactical situation had completely changed. Schneider ignored the orders. He completed the withdrawal, consolidated his remaining forces in defensive positions. He sent another courier to division explaining what had actually happened. That courier returned at 0930 with new orders acknowledging the situation had changed. But by then, American forces had advanced past Schneider's position, rendering the new orders irrelevant. This was typical of German operations in 1945. Plans based on outdated intelligence, rigid execution despite changed conditions, communication failures at every level, commanders making decisions with incomplete information, units operating blind while the enemy operated with perfect situational awareness. Schneider later learned what the American 3rd Armored Division had been doing during that same engagement. Every tank commander in the American division was on a radio net. When Schneider's battle group was spotted by American reconnaissance, that information was instantly broadcast to all American units in the sector. Company commanders immediately began coordinating response. Some companies moved to fix Schneider's force in place. Other companies maneuvered to flank positions. Artillery observers called fire missions directly, without routing requests through multiple headquarters layers. The entire American response, involving dozens of separate units, was coordinated in real time. Tank commanders adjusted their movements based on instant updates about where other friendly units were. Company commanders could request air support and receive it within minutes. The American division commander could monitor all radio nets simultaneously, understanding the entire tactical picture without waiting for formal reports. When Schneider's force began withdrawing, American commanders recognized it immediately because their lead elements were reporting enemy movement in real time. They adjusted pursuit tactics instantly. They positioned forces to cut off withdrawal routes. They concentrated artillery fire on choke points. All of this coordination happened within minutes, not hours, because everyone could communicate instantly. The contrast was absolute. Schneider commanded his battle group essentially blind, making decisions based on information that was minutes or hours old, unable to coordinate effectively with his subordinate units, dependent on a communication system designed for 1930s warfare. The Americans commanded with complete situational awareness, adapting in real time to battlefield developments, coordinating hundreds of vehicles as if they were a single organism. The technological basis for this American superiority was brutally simple: mass production and standardization. The United States produced over 500,000 military radio sets during World War II. The SCR-508, designed for armored vehicles, entered production in 1941. By 1945, virtually every American tank had one. Production was handled by multiple manufacturers: Galvin Manufacturing, which became Motorola; Western Electric; General Electric. Multiple factories producing identical equipment to identical specifications. This redundancy was critical. When one factory was retooling or expanding, others maintained production. When shortages of specific components appeared, engineers redesigned around available materials. The entire system was designed for resilience and scale. German radio production, by contrast, was concentrated in a handful of specialized firms: Telefunken, Lorenz, Siemens. These companies produced excellent equipment, but in limited quantities. When Allied bombing damaged factories, production dropped. When material shortages appeared, there were no alternative suppliers. By 1945, German armoured units were operating with a mix of equipment dating back to the start of the war. Panzer IIIs with radios from 1940, Panzer IVs with radios from 1942, Panthers with the newest equipment, but even that was based on technology from 1943. Maintenance was a nightmare. Each radio model required different spare parts, different technical knowledge. Signals personnel needed to be familiar with multiple systems. American forces had the opposite advantage. Standardization meant every radio operator trained on the same equipment. Spare parts were interchangeable. Maintenance procedures were identical across all units. When a radio failed, replacing it was simple. Pull the broken unit, install an identical replacement, transfer the frequency, settings. Total time, perhaps 15 minutes. German radio replacement could take hours or days, assuming replacement equipment was available at all. The training differential was equally stark. American radio operator training took approximately 4 weeks. The curriculum was designed for mass production of personnel. Students learned basic radio theory, operating procedures for standard equipment, basic troubleshooting. The training assumed students had no prior technical knowledge. By contrast, German signals training took 12 to 16 weeks and assumed students had technical aptitude and education. The quality of individual German signals personnel was higher, but America could train 10 operators in the time Germany trained 1. This matched the overall American approach to the war. Design systems that worked with adequate personnel rather than requiring excellent personnel. Create equipment that functioned reliably in the hands of average soldiers. Build an army that could scale quickly because it didn't depend on years of professional military training. Germany's opposite approach, building a military that required professional skill and lengthy training, worked brilliantly when Germany had time to prepare and train. By 1945, with casualties mounting and training time compressed, the German system collapsed. Schneider saw this firsthand. His signals personnel in March 1945 were mostly replacements, young soldiers with minimal training. They could operate radios under ideal conditions, but struggled when equipment malfunctioned or when combat stress impaired their judgment. The veteran signals specialists who'd been with the unit in 43 and 44 were mostly dead or transferred to other units to provide experienced leadership elsewhere. The American approach of building foolproof systems meant even inexperienced American radio operators functioned effectively. The equipment was designed to be intuitive, procedures were standardized and simple. Even under stress, even with minimal training, American soldiers could maintain communications. This resilience was the product of industrial design philosophy. American engineers assumed equipment would be operated by people with limited training under terrible conditions. German engineers assumed equipment would be operated by trained specialists under controlled conditions. April 3, 1945. The Ruhr Pocket. Schneider's battle group, now down to 8 operational Panthers and 1 company of infantry, was trapped in the shrinking pocket of German resistance. Allied forces had encircled over 300,000 German troops. The pocket was collapsing. Supply was non-existent. Communication with higher command had been lost days ago. Schneider was listening to American radio traffic again. His signals officer had kept the captured SCR 508, monitoring American frequencies to gain intelligence about enemy movements. What they heard was orchestrated destruction. American and British forces were systematically reducing the pocket, and every movement was coordinated by radio. Artillery strikes were called in real time by forward observers. Airstrikes were coordinated with ground advances to prevent friendly fire. Tank companies coordinated their attacks to maintain continuous pressure. The Germans inside the pocket were fighting blind. No communication between isolated units, no coordination of defense, no knowledge of where friendly forces were or where the enemy was advancing. Individual commanders made desperate last stands without knowing if their sacrifice accomplished anything strategic. Becker, listening to American traffic, provided Schneider with better intelligence about the overall tactical situation than Schneider could get from German sources. The Americans are advancing from the west and south simultaneously. British forces are pushing from the north. They're coordinating the advances to prevent any German forces from breaking out. Every unit knows where every other friendly unit is positioned. Schneider made a decision. Continuing to fight was pointless. His unit would be destroyed without accomplishing anything. On April 8th, he surrendered his remaining forces to the American Ninth Army. His war was over. During the post-war period, American intelligence officers interrogated thousands of German prisoners, including Schneider. The interviews were part of systematic effort to understand how German military effectiveness had declined so dramatically. One question appeared repeatedly in interrogation reports. How did American forces coordinate so effectively? German officers, trained in traditional military theory, couldn't understand how American units maintained cohesion and coordination, despite appearing tactically unsophisticated. Schneider's answer, preserved in intelligence archives, was direct. American coordination came from their radios. Every tank had a radio. Every commander could communicate instantly. They could adapt to battlefield changes immediately while we were still trying to understand what was happening. Our doctrine assumed commanders would lead from the front with direct observation. American doctrine assumed commanders would coordinate through radio communication even when they couldn't see each other. In modern warfare, their assumption proved correct. Other German officers provided similar assessments. General Oberst Alfred Jodl, Chief of Operations Staff at OKW, stated during interrogation that American communication superiority allowed them to concentrate forces rapidly and coordinate combined arms operations with unprecedented effectiveness. General Siegfried Westphal noted that German forces in the West were consistently outmaneuvered because American commanders had real-time situational awareness, while German commanders operated with delayed and incomplete intelligence. The statistics supported these assessments. American armored divisions in Europe typically had over 1,200 radio sets of various types. German Panzer divisions had perhaps 200 radios, many of which were non-functional due to maintenance issues or parts shortages. American communications networks extended from frontline tank commanders all the way to supreme headquarters. German communications networks were fragmented, often breaking down at division or corps level. The production numbers were even more telling. From 1940 to 1945, Germany produced approximately 150,000 military radio sets of all types. The United States produced over 500,000 military radios in the same period, and American radios were more reliable, easier to maintain, and designed for operators with minimal training. The force multiplication effect was extraordinary. An American armored division with effective communications could coordinate operations across a front of 50 kilometers. Every tank commander knew where friendly forces were. Every company commander could request support and receive it within minutes. Artillery observers could call fire missions directly without routing requests through multiple headquarters. A German Panzer division, even when at full strength, struggled to coordinate across a 20-kilometer front. Company commanders often didn't know where neighboring companies were. Requests for artillery support went through multiple headquarters layers, introducing delays of 30 minutes to several hours. Tank commanders operated with information limited to what they could personally observe. The American system created emergent capabilities that exceeded the sum of its parts. Individual tanks, individually inferior to German Panthers or Tigers, became devastating when coordinated as integrated formations. American tank tactics, relatively simple compared to German sophistication, became effective when every tank could instantly communicate threats, coordinate flanking movements, and mass fire on targets. This phenomenon, force multiplication through communications, became the foundation of modern military doctrine. Today's military forces are even more dependent on instant communications than World War II armies. Network-centric warfare, the current term, describes operations where every element is connected through digital communications, sharing real-time intelligence, coordinating actions across global distances. The concept traces directly back to American radio doctrine in World War II. Modern infantry squads carry radios that would have seemed miraculous to 1940s soldiers. Satellite communications link frontline troops to headquarters thousands of miles away. Drones provide real-time video feeds. Digital networks allow every soldier to see the same tactical picture simultaneously, but the fundamental principle remains identical to what the Americans demonstrated in 1945. Give every combat element reliable communications. Create networks that allow information to flow in all directions. Train personnel to use communications equipment as naturally as they use weapons. The Germans learned this lesson too late. Post-war German military forces, particularly the Bundeswehr, created in the 1950s, adopted American communication doctrines completely. Modern German armor units use networked communication systems virtually identical in concept to what the Americans deployed in World War II. The technical sophistication has increased dramatically, but the underlying doctrine, that effective communication creates decisive tactical advantage, came directly from the German experience of being defeated by an enemy with superior coordination. Ernst Schneider survived the war, returned to his pre-war profession as an engineer. In a 1963 interview for a German military history project, he reflected on his wartime experience. The interviewer asked what single factor had been most decisive in German defeat. Schneider's answer was immediate: communications. The Americans could coordinate 500 tanks as if they were one vehicle because every tank commander could talk to every other tank commander. We fought as individual companies, sometimes as individual tanks, because we couldn't communicate effectively. Superior German tactics and tank design couldn't overcome American ability to mass forces exactly where needed, exactly when needed. They could do this because they had radios and doctrine that used radios effectively. We had neither. The Battle of the Bulge in December 1944 provided the clearest demonstration of this communications gap. Germany launched its last major offensive with surprise, concentration of force, and favorable weather that grounded Allied aircraft. Initial German success was dramatic. American forces were pushed back. Entire units were surrounded. For 48 hours, it appeared the German offensive might succeed. Then American communications superiority reasserted itself. American commanders, despite initial confusion, quickly established the overall tactical picture through radio networks. Units that had been overrun reported their positions and enemy strength before being destroyed. Surrounded units, like the 101st Airborne at Bastogne, maintained radio contact with higher headquarters, allowing relief operations to be coordinated. Most critically, the American Third Army, commanded by General Patton, reoriented 90 degrees north and counterattacked within 72 hours. This maneuver, involving 250,000 men and thousands of vehicles, required instant coordination across multiple divisions. It was possible only because American forces had reliable communications at every level. German forces in the Bulge, despite initial success, couldn't exploit breakthrough because they couldn't coordinate effectively. Spearhead units advanced beyond radio range of headquarters. Company commanders didn't know where neighboring companies were. Requests for fuel and ammunition got lost in the communication chain. When American counterattacks came, German forces couldn't respond cohesively because isolated units were fighting their own separate battles without coordination. The Bulge demonstrated that tactical skill and operational surprise couldn't overcome systemic communication inferiority. Germany's best remaining units, led by experienced commanders, executing a carefully planned offensive, were ultimately defeated because American forces could coordinate response faster than German forces could exploit success. The radio networks that seemed like excessive luxury during peacetime became decisive advantage in combat. The American investment in communications, technology, and training created capabilities that German tactical excellence couldn't counter. Final statistics illuminate the scale of American communications superiority. By May 1945, the U.S. Army had approximately 13 million personnel. Over 2 million of them had received radio operator training. That's 15% of the entire army trained to operate communications equipment. The German Wehrmacht, at peak strength of 13.6 million in 1943, had perhaps 200,000 trained signals personnel, less than 2% of total force. American doctrine assumed everyone would communicate constantly. German doctrine assumed communication would be centralized and controlled. American equipment was designed for reliability and ease of use. German equipment was designed for performance and sophistication. American training prioritized rapid production of adequate operators. German training prioritized creation of expert specialists. Every one of these doctrinal and technical choices reflected deeper cultural values. American culture valued mass production, standardization, and democratization of technology. German culture valued craftsmanship, specialization, and professional excellence. In peacetime, or in conflicts between relatively equal opponents, the German approach had advantages. Professional skill and sophisticated equipment produced superior results. But in total war between industrial powers, the American approach was decisively superior. Systems designed for mass production could scale to meet unlimited demand. Equipment designed for average users remained functional when experts were unavailable. Doctrine that assumed constant communication created adaptable forces that could respond to unexpected situations. The German Panzer crew that captured American radios at Remagen discovered a truth that determined the war's outcome. Technology matters, but doctrine matters more. Germany had the technical capability to build radios as good as American equipment. German electronics firms were world leaders in radio technology before the war. What Germany lacked was doctrine that recognized communications as decisive rather than supporting capability. German military culture viewed radio with suspicion as potential security liability rather than tactical asset. American military culture embraced radio as fundamental to modern warfare. This doctrinal difference created cascading effects. Doctrine shaped procurement decisions, which shaped industrial production, which shaped training programs, which shaped tactical capabilities. By the time German commanders recognized that American communications superiority was decisive, Germany lacked the industrial capacity, the trained personnel, and the institutional flexibility to adapt. The war was lost not in any single battle, but in thousands of small tactical actions where American coordination overcame German skill. Ernst Schneider's discovery at Remagen that Americans coordinated 500 tanks like one brain revealed the future of warfare. Modern militaries understood that victory required not just weapons, but information systems that allowed those weapons to be employed with perfect coordination. The simple radio set, mass-produced by consumer electronics companies, had transformed warfare as fundamentally as the tank or the airplane. Germany learned this lesson by being destroyed. The world learned it by watching Germany's defeat. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.